In this section, we're going to solve these equations using graphical method. By solving, I mean finding the roots of an equation. Usually, an equation like this equation, usually we factorize. So this equation is easy. It's easier to factorize, and factorize to give us a root of x equal to 3 and x equal to 1. And if we are plotting this graph, we can easily show that the roots are plus 1 and plus 3. Why would you go through this method of plotting to find the roots? Is it not easier just to factorize? Yes, it's easier to factorize. In this case, it's easier to factorize. But in many cases, we are not able to factorize the equation and finding the roots. So we have to go through the graphical method of finding the roots. And the way to do that is to take this equation here, and rearrange it, make it x squared equal to 4x minus 3. Then we can plot each of these functions on its own. So we plot x squared and we plot 4x minus 3. So we make this equal to y and we make this equal to y. Then we can plot it on one graph, as we will see from the next diagram. So all I've done here, I've rearranged the equation into this format here, and then plot x squared on its own, and that is the x squared, the parabola, and it's going through the origin, that's y equal to x squared, and then plot this equation on its own, and that is a straight line cutting through minus 3 here, and it's that line, y equal to 4x minus 3. And you'll notice that they intersect at this point here, x equal to 1, and at this point here. So that means we have two roots, and this is plus 3. Exactly the same as we had here. Plus 1 and plus 3. And that's solving using graphical method. So to summarize, you rearrange the equation into an easier form to plot. We rearrange, and then we plot the two curves, and where they intersect, that will give us the two roots of an equation. We will do more examples and this will be clearer. Okay, let's do this example 1. It's in your notes in the bright space, and it's the first thing we do is we have to rearrange this equation here. You can see this is difficult to solve using factorization, and it's difficult to plot as it is. So we're gonna arrange it into two equations. We arrange it into, we say e to the minus x equal to, we take x to the other side and becomes x minus 1. So we're gonna draw this graph on its own, and this graph. This is straight line graph, and it's, so this is the straight line, that's y equal to x minus 1, and this is y equal to e to the minus x. It doesn't touch, just goes it doesn't touch the x-axis, and it cuts the x-axis at this point here, which is +1. Now we can see that they intersect here in this point. It's between 1 and 2. The intersection point is here. That is the intersection point. And from here we can find the root. And there is only one root. So the root lies between 1 and 2. It's bigger than 1 and smaller than 2. So only one root for x between 1 and 2. All we've done is to plot these two. We plotted this graph, and that's y equal to e to the minus x, and this is straight line. And what I suggest, you go back to the section on graphs on week 8, and it will show you all the basic graphs, and that's one of the basic graphs that you need to know. Y e to the minus x, or y e to the power plus x, straight lines. And it's useful to go back and revise it under week 8 work. Here we do the same. We rearrange this function here so that we can plot sine x, that's hyperbolic sine of x, and we can plot the x minus 3 on its own, and the point of intersection will give us the root. So this equation will be sine x equal to minus x plus 3. So we plot the sine x, which goes through the origin, and that's one of the basic graphs that you should know. If you go back to section 8, the graphics on week 8, that will be one of the graphs. So that is y equal to sine x, and we plot this graph here. That's a straight line graph, and it's going through it, cutting the x-axis at 3 and the y-axis at 3. And this point here, well, it's not 1, but it's not exactly up to scale, but we have a root here. The root lies between it's bigger than 0 and it's smaller than 3. So the root's somewhere between 0 and 3. There's only one root. It's only one root because these graphs, they only intersect at one point. This graph, the sine graph, and the straight line, they only intersect once, and it's somewhere between 0 and 3. That is the solution to example number 2. You can have a go at example number 3 now, and you should be able to solve all the questions related to this section.